Bismillah ar-Rahman ar-Rahim. This is me, Dr. Karim Ayesh. I am associate consultant at the Maghrabi Eye Hospital in Jeddah. I am associate consultant with Dr. Muhammad Ali al-Danasouri. I would like today to talk about MS39 as one of the newest devices in corneal assessment. He is composed of placebo measurement and spectral domain OCT. The main objective of the lecture is an overview on anterior segment OCT combined with placebo, and to share information with my colleagues and my professors about what can MS39 added to us in order to good screening of refractive surgery and good tool in diagnosis of corneal diseases. My main acknowledgement is to Dr. Muhammad Ali al-Danasouri. He is a chief medical officer of Maghrabi Eye Hospital. He has a lot of innovation in refractive and corneal surgeries, and he has also a lot of innovations in corneal assessment devices. He is one of the doctors that contribute in the formation of MS39 software. And we have to be, as an Arab doctor, we have to be proud that we have Dr. Muhammad Ali al-Danasouri as an Arab doctor, as one of the international Arab doctors all over the world. I have no any financial disclosure. What is MS39? MS39 is a high definition spectral domain OCT. Its wavelength is 840 nanometer plus placebo disc. What is the meaning of a spectral domain OCT? Before, it was time domain OCT. Time domain OCT means that the machine has single wavelength monochromatic light. Its wavelength is 460. While the light is emitting from the device and reaches the eye, half of the wavelength goes to the eye and half of the wavelength goes to reference mirror. And by reflecting both of them, they reaches a photodetector. And by constructive and destructive interference, the machine calculating the surface. And after the machine obtained layer, they send another light, and this procedure takes time, so it's time domain. And also it depends on too many calculations, because it cannot be able, the machine cannot measure the whole layers at the same time, but assuming or calculating other points. It just measures some point and calculating others, so the resolution is bad. But in spectral domain OCT, it can the machine send a spectrum of light, different wavelengths. In our machine, in MS39 machine, it reaches 840. At the same time, it sends light of different wavelengths to the eye, so it has deeper depth or more depth than the time domain at one single shot. So it's time consuming and it has a better resolution. And later on is the swept source OCT. It has a wavelength 1300, so it has a better depth with a better resolution. What is the meaning of a placebo disc? Placebo, before, the first information before they can obtain about the corneal surface is through Dr. Placebo in 1883. He just has placebo mirrors, and he can see its reflection on the cornea, and after that he obtained the corneal shape, but it was qualitative measurement or qualitative assessment of the corneal surface. And after that, by Dr. Gulstrand and the Gulstrand ratio and the Gulstrand measurement, they measure الcorneal power through according to the visual axis of the machine. They compare أو they measure الcorneal power according to the visual axis of the machine أو emitting light of the machine, and it measures the radius of curvature according to this light emitted from the machine. And they assume or they consider at that time they don't have any information about the posterior surface. So they fix that the refractive index of the cornea is 13375. And after that they obtain key readings called simulated key readings. So to summarize, simulated key readings is the key readings that obtained from the machine, obtained from a radius of curvature of the emitting light of the machine at certain point at the cornea, assuming that the refractive index is 13375. But after that, after they got information about the posterior surface, they can obtain a true corneal power, and it has different nomenclature according to the machine. In our machine means it's called mean pupillary power. Mean pupillary power, they are using the true refractive index of the cornea 1376, and they are using the anterior and the posterior surface, and then they can obtain a true corneal readings or nearby the true corneal readings. What we can use the MS39 for? We can use it in screening for refractive surgery, follow-up of refractive surgery, early detection of keratoconus, follow-up of keratoconus in ICR module, ICL volt, corneal scar, keratoplasty, glaucoma, IL calculation, dry eye. This is a matter of software also. This software, it has these modules, and these modules can be added in another devices, but I'm talking about this software that I'm usually working daily. What is the specification of this device? Placido disc ring 22. It covers more than 80% of the corneal surface. It reaches 10 millimeter diameter, and it gives us a measuring point in the anterior surface 31,232, and in the posterior surface 25,600. Before Placido, the first Placido devices was flat surface. In this flat surface, you can just obtain 60% of the central corneal surface. But after that, they invented what is called collimating Placido surface. What does mean collimating? Collimating means curved Placido. The device itself is not flat, it's curved. So it can cover more than 60% of the corneal surface. Dioptric measurement range from 1 diopter to 100 diopter. يعني it can measure from 1 diopter to 100, and it has image field section horizontal distance 16 or vertical distance 8, and it has axial resolution more than 3.6 micron in tissue. What does mean? That mean, or this mean that if you have 2 points, the distance between them 3.6 or more, the machine will detect them as a 2 point. And if this distance is less than 3.6, so the machine will detect them as 1 point. This is the strong point, one of the strong points that you can buy a machine or not to buy a machine. The axial resolution, even if you want to buy TV, this is the meaning of axial resolution. And in air 35. Okay, type. What is the meaning of a scan? A scan, this is the light that capture any point. This light called a scan, but multiple light adjacent to each other or nearby each other, it called P scan. Here I need to talk about why we have to use MS39. What is the advantage of MS39? MS39, as we said, it's spectral domain OCT plus placebo, but a true placebo measurement, or we can say curvature based or curvature assessment. It measure curvature through measurement of curvature of the cornea, unlike just elevation based tomography. Elevation based tomography is just measuring the curvature of the cornea through measuring anterior points or posterior points, just points, and point by point they obtain the curvature. But here in curvature based tomography, it's a true measurement of the curvature of the anterior surface of the cornea. Plus, it has the ability to measure anterior point and posterior point and get all the information about the elevation and about the corneal thickness and about the calculated aberrometer. And also, additional, we are using OCT by its advantage of OCT. It's unidirectional, it's collimating light, it is constructive interference, it didn't affect so much by scatter. Unlike light, blue scatter light of the Champflug images, it's really affected by scattered. And also, OCT can give you informations about the layers of the cornea, sections. MS39 or this software gives us too many maps, and it has a pattern deviation map. This is very important point. Pattern deviation. That means this cornea is in comparison to normal cornea at the same age or same population, like a visual field, pattern deviation in the visual field. It has pattern deviation in all maps: corneal, epithelial, stromal, and so on. And this software, it can measure corneal curvature through axial map, ودي البيزلاين أو البنشمارك, and the tangential اللي هي more reliable, and Gaussian curvature. They said or they claim that the Gaussian map is the true map of the cornea, the true shape of the cornea. MS39 gives us information about what is called ectasia indices, calculated aberrometer, not measured. MS39, it doesn't have aberrometer. it's just measuring الابيرومتر from anterior and posterior elevation points. It has in the software it can give us classification of this cornea. If it is keratoconic, if it is borderline, if it is normal, if myopic ablation, and so on. And also we can obtain subtraction map. There is some this study is done by Theo Seiler about the accuracy of MS39 and Pentacam and the repeatability. What is the meaning of repeatability? Repeatability means if you, for example, if you have patient has K reading 43 and K1 43 and K2 44, and at the same time you did another exam 43 44, at the same time third exam 43 44, and after 1 week 43 44. Okay, and if another optician did the same examination برضو 43 44. So this machine is very reliable, you can depend on its number. Okay, they found in this study that in comparison between the Pentacam and the MS39, they give the same result or the same repeatability in normal patients or normal cornea. But in mild and moderate keratoconic patients, the MS39 is more reliable. This is the acquisition of the machine. ازاي بتاخد الصور. All studies and in most refractive centers you have to take 3 exam per time at once. 3 exam and take average between them. And if the patient is moving or uncooperative, you can take more to capture the average between them. The average, how you can decide between average. Here in MS39, if you see here, it's a keratoscope quality. It's quality of the Mayers. And the Placido coverage, it cover how percent of the cornea. If it is more than 80%, you have the information that you want. Section coverage, section of OCT. So you have to take average between them. Okay, and this is the average between the same K. Here I am looking at this number. I am taking average of this number of cylinder. Okay, and this is the central corneal thickness. You have to take average of central corneal thickness and the average of pupil center and the average of keratoscope center. This is to obtain the best examination. And also MS39 by different illumination in the device, it can measure a pupil diameter in photopic illumination and mesopic illumination and scotopic illumination. Now, this is the example. The patient has a 2.9 photopic, 4.07 mesopic, 4.5 scotopic. This is the XY of the pupil center in comparison to the visual axis. Here we can, in photopic condition, you can obtain angle kappa. Angle kappa is the difference between the pupil center, or center of the pupil, and the visual axis. This is the X and Y. This is X and this is Y. Here I want to talk about corneal summary best fit sphere or best fit toric ellipsoid, as you want to change from settings. This is the baseline map. This is the baseline maps that we decide upon it. Here, as you see, K flat, K steep, K average, cylinder on the anterior surface, K front map max thick minimum thinnest point of location أو location of the thinnest point epithelial thickness minimum white adjusted this number is the most reliable number that we are calculating الفكك IOL and we are using this number in all our calculators in our unit. This is the central corneal thickness, A equals depth. A equals depth, this is the measurement from the endothelium to the anterior lens capsule. But AC depth or A equals EC depth, anterior chamber depth, is from the epithelium that is obtained from IOL master. And here what is the meaning of best fit sphere, best fit toric ellipsoid? Before after the innovation of elevation based tomography, they just obtain numbers. This point is elevated, this point is depressed, this point is elevated, this point is depressed, but it doesn't have a certain shape. So it is difficult to differentiate between normal cornea from keratoconic cornea or suspicious cornea. After that, they compare this cornea by certain shapes, like part of a sphere or like part of ellipsoid, and compare this shape that we are knowing the diameter of it. They compare it by this cornea. If the cornea is steepened or has a steepening more than this shape, so it gives you plus sign and it gives you hot colors. If it is flattened than this shape, so it will be cold color or negative sign, and so on. And mostly best fit sphere, this is the usually used. We are usually using best fit sphere in all papers and the most of screening of refractive surgery upon best fit sphere. But the more true or the more reliable is the best fit toric ellipsoid, because the cornea is part of ellipsoid or part of toric. It's not spherical in shape, so you cannot compare between sphere and square. You cannot compare between circle and square. You can compare between circle and the circle. So especially in astigmatic eye or keratoconic or suspicious eye. This is the shape of the same patient. This is the shape of the same patient by best fit toric ellipsoid. The numbers in myopes في البيست فيت sphere in myopes في الانتيريور elevation و posterior elevation. Anterior elevation 8, posterior elevation 18. في الهاي بروب 7 and 28 في posterior elevation. And in best fit toric at the thinnest point في anterior elevation it must normal يعني less than 12 and the posterior elevation less than 14. This is map tangential anterior curvature. This is the maps that we can obtain. Tangential anterior curvature, tangential posterior, axial anterior, axial posterior, Gaussian anterior curvature. Gaussian posterior curvature, I will give you some small information about the difference between them and what is the advantages of them. Anterior elevation, stromal elevation, posterior elevation, refractive equivalent power, refractive anterior power, refractive posterior power. What is mean refractive? This is equivalent to in Pentacam اللي هو equivalent key reading and the total net power. This is the actual key reading. The actual key reading, they use Snell law and the ray tracing. They are using a refractive index, the true refractive index of the anterior surface and the true refractive index of the posterior surface, and is abstracting between them. They used here refractive index of the total cornea 1376, not 1336. لا, they are using here اللي هو 1376 refractive index, and they are using السنيل law أو ray tracing to get what is the true key readings here, and this is used in post-refractive surgeries to know because why in the post-refractive surgery we cannot depend on the same key reading, because post-refractive same key readings, they consider fixed relation between anterior and posterior surface, but in post-refractive surgery this relation is disrupted, so you must know the true refractive surgery, true corneal power. How can you know it? By measuring the anterior surface, by measuring the anterior surface and measuring the posterior surface, and add them and put a calculation and using the true refractive index to to approximate to the true corneal readings. And the Barrett, Troquet, and so on, they are using this mathematics, they are using these concepts. This is and we have here corneal thickness, epithelial thickness, stromal thickness. Epithelial thickness, this is very important to screen a patient for refractive surgery, and knowing everything about the cornea, even epithelial map, even epithelial thickness, and even epithelial pattern. Epithelial pattern, and we will see later in this presentation, it gives you very important information in diagnosis of subclinical keratoconus. And it gives you information about anterior chamber depth in each point in the anterior chamber, and the keratoscope, and gives you information about the iris, and so on. This is a summary indices. Here, like I said before, a thick minimum, epithelial thickness, stromal thickness, minimum, and the corneal volume, and the K-max front surface, and the K-max back surface, and the Gull-Strand ratio. This is the ratio, the fixed ratio between the anterior surface and posterior surface. And this is the pupil, this is the photopic pupil, and this is the angle kappa, X and Y, lower Castorian distance. And here you can, from setting, you can change it from Castorian and Castorian and Polar. Polar, it gives you the degree, the actual distance and the degree of at which degree of the angle curve. Center corneal thickness equals depth. Lens rise. The lens rise, it's measured. The machine draw one line from the iridocorneal angle here, iridocorneal angle here, and they draw line, a straight line, and they are seeing what is the position of the lens in comparison to this line. If it is above this line, it gives a negative sign. If it is below this line, it gives a positive sign. Below this line, this means lens itself, crystalline lens, it has high voltage. This, in the future, I think it can be considered in intracolumnar lens refractive surgery or phakic IOL refractive surgeries. This is the scleral spur to scleral spur lens, and white to white, and the EC tilt او التلت بتاع EC بتاع البيشنت. This is the key readings, same key readings, simulated key readings that illustrated before. This is what is called peripheral degrees. This is the most important number. This is the shape of the cornea at different degrees, at different circles, at different diameter of the cornea. The most important is these numbers. At 20 degree, it's equivalent to 4.5 millimeter. This is the average number. This is the corneal asphericity أو الcorneal shape. with normal بيبقى minus 0.23 0.3, and if you are more than more minus so this cornea is prolated cornea, like in keratoconus. If you are in toward a plus sign, so you are oblated cornea, so, as post myopic ablation. This is the key reading posterior. This is the shape indices. You can decide what is the diameter of the pupil you want to measure. This number is very important. They compare between الهاي اوردر aberration اللي هو الكوما والسpherical والتريفويل in the area that could be affected more in keratoconus, and they compare it between us. If it is in the green line, so it is more than 95 percentile. If it is in the yellow line, so it is more than sorry, if it is in the yellow line, so it is more than 95 percentile. If it is more than a red line, it's more than 99 percentile. What is the meaning of 99 percentile, 95 percentile? If the patient is red zone, so the population more than 99 percentile of the population better than this measurement. So if you have this measurement, so you are abnormal, because more than 99 percent of the population is above these numbers, and so on. This is refractive analysis. This is the mean pupillary power, that what I illustrated before, اللي هو true corneal power at the pupil at the 3 millimeter diameter, and we use it. We use this number post refractive surgery. And this is the slender. What is this? This is the longitudinal spherical aberration. They measure the machine itself. It's measure longitudinal spherical aberration and measure longitudinal chromatic aberration. And you give the U number, and this number it's compared to the population. If it is more than 99 percentile or 95 percentile. This is the high order aberration, the calculated aberrometer high order aberration upon the cornea. As 3 millimeter, we are using usually at 5. If you want to know this patient, all the studies they use a high order aberration root mean square at 5 or 6 millimeter pupillary diameter. If it is more than 0.5 or 0.6, so this patient has a high order aberration, and you can know, and later I will illustrate, you can know what is the type of the high order aberration. It is coma, it is spherical, it is traumatic trefoil, it is astigmatism, or what? Astigmatism, it has a low order and high order. Part of astigmatism has a high order aberration. This is keratoconus screening. This is very important tool, very important tool, and this is the classification. What is mean is symmetry index front. Symmetry index front, we will jump on the next slide to understand symmetry index front and corneal symmetry index front. Central or centroid symmetry index front والsymmetry index front والectasia indices front والectasia indices back, and so on. I will illustrate what is اللي هو thickness increase max and what is the classification. This is the symmetry index. They draw circle here. This is the center of the cornea, the temporal part, nasal part. They draw circle like this and circle like this, and they measure mean Gaussian curvature in this area and compare it by this area. If it is abnormal, it will be in the yellow line or yellow area or red area, low 95 percentile and the 99 percentile. They compare between the difference between curvature, because this area is the hot area of keratoconus. If this area has a mean Gaussian curvature, Gaussian, they are using a Gaussian, and we know that the Gaussian is the true power that measure the corneal surface well. So if it is here is more than the upper part, the lower circle is more than the upper circle, so this patient is suspicious. And this is the central centroid index. The same concept, they measure, they put in a 6 millimeter, 3 millimeter diameter around the center of the cornea, and 6 millimeter diameter. and they compare المين curvature here بالمين curvature here, and so on. It measures this in the anterior surface and posterior surface. طب what does mean about الectasia indices in the front and back? This is what I illustrated before. They measure the corneal aberration in the areas that could be affected more in keratoconus. Thickness increase max. I will illustrate later on. This is the classification that the machine gave it to you. This is artificial intelligence, and it gives you information if this cornea is normal, borderline keratoconus, or other, or myopic ablation. This is the map. We have curvature map. Curvature map اللي هو عندنا الأكزيال. Most studies are talking about axial, and this is the benchmark that refractive surgeon or any refractive surgery we can talk about the axial anterior curvature. But later on they found that the axial anterior curvature is more affected by alignment. And if the patient is not seeing well at the target or at the point inside the machine, it may give you false or pseudo ectasia. But the tangential is less affected. Gaussian this is the true map. The true map of the cornea. It measures the cornea, and this is the best map. You can see the ectasia. In the next slide, this is a simple illustration about the difference between axial, tangential, and the Gaussian map. Axial map, they measure the radius of curvature according to the light of the machine, the viewing light that the patient is concentrating on it. So it measures the radius of curvature of each point in comparison to this light. Okay, lower visual axis. What is mean a visual axis? But they found later that the axial map give us a false shape of the cornea. The cornea, it doesn't have a bow tie. The cornea, it just have numbers. And the axial map is more affected by misalignment, because every point in the cornea is measured according to what is the patient is seeing. And if the patient is seeing in another area rather than the light emitting from the machine, it may give you false ectasia, or false readings, or false impression on the cornea. But in tangential map, this is more true than an axial map, and more reliable and less affected by alignment. Unlike an axial map, it measures point by point, and as a circle here is put a circle that have a tangent on corneal surface. And by measuring the corneal radius, or by measuring radius of curvature of this circle, they can obtain key readings. And later on, they are inventing the Gaussian map. Gaussian map, I cannot understand the Gaussian map very well, and if anyone has more information about the Gaussian map, please share it with me. Gaussian map, as I understand from what I read, is put a circle in each point, around each point on corneal surface, and they are measuring radius curvature of this circle. Gaussian map, they claim that that is the true map of the cornea. the true map of the cornea, and it doesn't have the shape of the bow tie. The more reliable in localization of the cone. This is one of the this is one of the advantage of this software. It gives you keratoconus map. Look here, it's an axial anterior curvature, anterior and posterior. This is Gaussian anterior and posterior. This is anterior elevation versus normality, اللي هو pattern deviation, اللي هو relation between this point in comparison to normal vibration at same age. And this is the posterior elevation versus normality. And this is the whole epithelial thickness. This is the comparison between this epithelial thickness in comparison to other population. And this is the stromal thickness, and this is the pattern deviation. This is the corneal thickness, this is the pattern deviation, and this is what is called the notable point. يعني thinnest point, corneal front max, corneal max back, and so on, epithelial thickness. If the notable point is near each other or in the red zone, so this cornea is suspicious. If it is like this, it's okay. This is a normal notable point spread. And this is that we are illustrated before. This is wavefront map of patient that has keratoconus suspect in the right eye and the keratoconus in the left eye. Look here, this is the OPD, this is the total, the low order and the high order, and low order and high order, yeah, and this is the high order aberration at the pupillary diameter 6 millimeter. This is the high order 0.6. Look here, this is the coma, longitudinal coma, longitudinal spherical aberration. This is the residual aberrations, which is the astigmatism, and this is the Zernike polynomials. You can know what is affected more in the aberrations. And here is the refraction of the patient at back vertex distance 12.5 minus 0.4. This patient doesn't have so much refraction in both eyes. This is keratoconic eye. You look here, a high order 0.8, and it has more coma. Here 0.6, here 0.4, and so on. It gives, but this is calculated aberrometer, not measured aberrometer. Now I need to talk about how to measure a functional optical zone. There is optical zone that we are deciding before surgery, and there is another term called functional optical zone. Functional optical zone is illustrated very well, very good in this study. They are using an axial anterior curvature map, and they are measuring the gradient of difference in key readings between the center of the cornea, our corneal vertex, toward the periphery until you reach 1 diopter gradient. And you can calculate it if your distance is on each side of, for example, each side of the corneal vertex. For example, the distance that have a gradient 1 diopter is 3 millimeter in this side and 4 millimeter in the other side. So the functional optical zone is 7 millimeter. And here, as you see, the number 7.28 is the number of functional optical zone of a patient post smart side lenticule obstruction, lenticule extraction. I hope you understand how to measure a functional optical zone. I studied a lot about how the ICR can work, but after I'm seeing the subtraction map, I better understanding of how ICR works. I draw here red line يعني resemble IC intracorneal rings. If you notice, this is the baseline axial anterior curvature, this is post ICR by 2 months axial anterior curvature. You notice here the difference between them in the subtraction map. The blue area is the area of flattening. Upon the head of the ICR, there is a lot of flattening, and the shaft a lot of flattening, and in front of the ICR there is a little stiffening. If you understand this map very well, or if you understand how can ICR works, you can plan for you can plan for better result in ICR cases. This is a tangential map, and also here a lot of flattening over the shaft here of the ICR. Look here, the high order aberration before it was 0.6, now it's 0.4 at 3 millimeter, but we have to measure it on 5 or 6 millimeter. But I want to show you that ICR it gives its effect very well, and this patient has 20/20 vision right now and is very happy, and but ICR is still unpredictable result. But here there is a lot of flattening, and the high order aberration, or quality of vision, it gets better. This is the corneal thickness. Look here, the thickness of the ICR is added to the thickness of the cornea. So you see here 163 or 227 diopters more, not diopters as the microns, more than the actual one, more than the baseline. This is a subtraction map. It's of the same case. This is one of the cases of Dr. Ala. You look here, this is before wavefront, before aberrations, and look here, it's much less flattening happened here. It's root mean square here 4.16. Here it will be 3.07. Type. This is how, through subtraction maps, this is how to measure ablation. How to measure ablation, you need to know after the surgery what is the power, what is the predictability and the accuracy of your machine. You can here know from the refraction before and the refraction after, and key reading before and the key reading after, and the subtracting between them to get the amount of flattening happened with the excimer laser or femtosmile. How to measure ablation depths, not bad the degree of flattening. Better to use the stromal thickness, because the corneal thickness it's affected also by epithelium, and the epithelium after surgery is mostly irregular. So you can here use stromal thickness. It's more reliable to know, to measure the predictability. If the machine before you are doing surgery, the machine gives you ablation depth 100, and you measured it is 120 in the stromal thickness, so the machine is ablating more than it gives you on the screen, and vice versa. Type. And you know, you can know here the centration. The central part is the most ablated. If the central part is the most part that be ablated, so the centration is good, especially in smile. And you can compare post cross-linking. This software is present in too many devices. This is intracorneal ring module. Very important here to understand how to, if you have a corneal ring, better to have a copy or print out digitalized to know how you will implant this ring, and what is the thickness of the ring, what is the incision angle, what is the bisecting line of the ring, and so on. Here, corneal thickness map, keratoscope, and axial anterior curvature, and the Gaussian map. It gives you 4 maps, the most important map. Okay? Here you can decide if you are using a center of the ring to be centralized on corneal vertex, اللي هو visual axis, or a limbal center or a pupil center. We are using in our unit a corneal vertex. You can use 1 ring or 2 rings as you like to use any specialized nomogram, or you have your nomogram. And the optical zone of the ring, اللي هو diameter of the ring. Usually the diameter of the ring, الفرارة or الكيرا ring, is 5 or 5.5 millimeter. Intracorneal amplitude, this is the arc. Arc, we are usually using big arc if the patient has a more myopia. We are using less arc if the patient more astigmatism. And the average, usually we are using 160 degree arc, يعني 160 degree arc. Okay, and this is the thickness. Thickness, I am deciding, usually I am deciding the thickness upon the main tunnel minimum thickness of the tunnel. يعني here مثلا in this situation or this case, the minimum tunnel, يعني we are doing here this is the 100 degree of the corneal thickness. Okay, so the corneal thickness at the incision will be لو يعني corneal thickness, the true corneal thickness 500 يعني 525. We are usually do the incision 70% of the corneal thickness at the incision side. Okay, so it will give you 368 micron, يعني the incision will reaches 368 micron. Okay, طيب الفيمتو laser will gives you a tunnel for the ICR. So if you have a 70 degree incision, so the tunnel will be average thickness, corneal thickness at the tunnel will be 367, and the minimum 347. So I'm usually using an ICR thickness below this number. Better to implant or easier to implant the ICR. If you have ICR thicker than this thickness, it will difficult to be implanted. Okay, and طبعا الرول if you put a rule of ICR, if you add any tissue in the periphery, it will flatten the center, and if the thickness is more, or if the thickness is more, so it will flat more the center of the cornea. I'm usually bisecting line of the ICR is the keratoconus axis on the Gaussian map. Not the, يعني look here, the axial axis. I'm not using the axial axis because it's not true. The true is the Gaussian map. The real map is the Gaussian map. I am using the keratoconic axis in the Gaussian map. Look here, the keratoconic axis is coinciding with the K-max on the Gaussian map. This is one case of keratoconus suspect. Here, inferior steepening, corneal thinnest point is 503, and feedback elevation plus 13 at the K-max. Suspicious cornea. Look here the details. Look here the pattern deviation in a plus 14 back elevation. But this patient, I excluded him by too many points. But especially look here the thickness of the epithelium. The epithelium here is thinner over the cone, over the elevation point. So I canceled this patient, and this is another patient of keratoconus suspect who do not sign. Look here, the epithelium is very thin over the elevation, and if you are seeing only axial anterior curvature, this is normal regular poti. But if you are seeing a posterior surface, here the elevation. If you are using Gaussian, here more elevation in Gaussian posterior curvature. في anterior elevation, في posterior elevation, في thinnest point of the thinning قصدي over the elevation on the epithelium. And look here, notable point in the red zone. And look here, thickness increase thickness increase percent, what is called corneal thickness spatial profile, or progression thickness increase. They put circles around. They put circles, I think, as I remember, 22 circles around the thinnest point of the cornea, and they are measuring a difference between thickness. يعني normally the center of the cornea our thinnest point is thin. Okay, if you are going peripheral, it will be thick. If you get thinner at some point, this is suspicious area. This is a suspicious area. So a thinnest point, our thinnest thickness increase percentage, it measures the corneal thickness from the center of the thinnest point to the periphery in 22 circles around the thinnest point. Like the corneal diameter that we are depend on is a 6 millimeter diameter from the thinnest point. This is the suspicious area of the cornea. طيب, this is one case of keratoconus. Look here in inferior stiffening, and here in back elevation on best fit toric ellipsoid, and you will see here the thinnest point of the epithelium, and thin, thick. Here, thin epithelium, thick epithelium. So this is suspicious area. Look here in notable point, and look here in thickness increase max is below 99 percentile. This is 99 percentile, with green line the normal, with blue line the low 95 percentile. If you are below 95 percentile, especially at below 3 millimeter, you are suspicious. 3 millimeter is equivalent to 6 millimeter in the pentacam. And you look here, it's all are red alert, and this is keratoconus. This is one of my cases after phakic IOL. First day it has a high volt, but the intraocular pressure was good, vision 20/20, and everything is good. So I complete follow-up with the patient, and after 1 week, the volt decreases from 1000 to 800, and this is toric ICL. So 800 is good for toric, not to allow the phakic IL to be rotated or something. This is 1 week, the same patient, 1 week after to measure the angle opening distance at 500 microns, 0.3 angle, it's 0.34, in normal 0.35. But this patient here, برضو also you can see difference in the anterior. This is the anterior chamber depth. This is one of the cases, برضو average volt. You are measuring how you can measure the volt. You are measuring the volt. This is the corneal vertex, our visual axis. You are measuring from the most points that curved in the posterior surface of the IOL, and the most anterior surface of the anterior lens capsule. That is the difference between the anterior chamber angle depth between before surgery and after surgery. Usually I saw that it decreases by 1 micron. This is how you can measure a demarcation line. Here, this is the demarcation and the depth of cross-linking. This is how can you measure a corneal scar. I have one case that have a corneal scar nasal in the cornea, nasal baras, أو nasal peripheral, and I was afraid about that I can this area it will not be dissected well while I'm doing the surgery for her. So I put the hinge of the corneal, the hinge of the flap on the nasal side, and it goes well, alhamdulillah. And another patient, this patient, the depth of this scar is 120. So I measured the depth of the thickness, and I choose to do flap 130 or 140 as I remember, and it goes well also. But if you don't have the number of the depth of this scar, so you can this area couldn't be easily dissected by femtolasic, and it could be trouble and buttonhole or something could happen. This is one case of Tyrian marginal degeneration. Look here, a very thinning point of the upper cornea, and this is the in-face image. This is one case of flap measurement for enhancement. You can know the flap even from a white line or from a black area, اللي هو area of dissected, it will be black. So you can measure a flap thickness in this area. This is one case of the patient told us that he has DULC. He did DULC, but after we are doing anterior segment OCT, we discovered that this anterior lamellar, not DULC, and this patient it has ectasia because it has this keratoconus. Keratoconus is continue, and it has ectasia because the whole stroma is not dissected, and it has a small diameter of graft. You know the residual, you will see here the residual of stroma. In the previous slide, here is contact lens warpage, epithelial map. Look here, there is inferior stiffening في tangential anterior curvature. If you don't have epithelial map, you will cancel this patient. But the posterior elevation is good. But sometimes you will be suspected in ectasia or something. But this epithelial map, it's ruled out because there is thickening here, thickening over the stiffening. Okay, this is ruled out it's ruled out keratoconus. This is one case I need to take your opinion about. You can think about it. Look here, there is ectasia in elevation in the temporal area, suspicious a little. And this is the keratoconus map. Anterior elevation is high, anterior elevation, high posterior elevation. Thinnest thickness of the epithelium is thin over the elevation. And you will see here in the corneal thickness become below the normal and return back in this thickness and this diameter, 2.5 from the center of the thinnest point. I cancelled this patient. What is your opinion about this patient? This is the other eye, the same anterior elevation, posterior elevation, thinning of epithelium, and look here, the curve is less than the right eye, and here the notable point is very close to each other. It's not in the red zone, but it's very close to each other. I cancelled the patient, and here it gives you warning sign. It's a borderline case. I cancelled this patient because it has a high degree of myopia. I cancelled corneal refractive surgery of this patient. Conclusion. The best conclusion of this study that you have here the advantages of true measurement of the anterior corneal curvature through Placido Mayers, and you can obtain too much information from elevation based tomography, and you have also sections of OCT that you can detect any type of scar, or you can measure any flap or depth of any scar. And if MS39 can measure axial length and the ocular aberrometer, and if MS39 has the ability or have the tool for aberrometry, so it will be the best device ever, but it will never happen because it will be so much expensive. Thank you so much for your attention. Feel free to add to me any further information or ask for any. Thank you so much.